You go. All right. We're good to go. Yeah.
Okay. Hello everyone, we're Team Blue Jeans and our project is GOAT, which stands for Genetic Online Annotation Tool. So let's introduce ourselves. My name is Jean.
I'm Joe. I'm Raphael. I'm James.
And last but not least, we have our wonderful coach, Bill. Our sponsor is Phoenix Bioinformatics, and they're an independent nonprofit biological research company where they were founded in 2013 on the West Coast. They maintain a site called TARE, where it keeps all the biological data for Arabidopsis thaliana, which is a model organism for plants, because all its genetic information has been sequenced. And my primary contact is Tanya, who is the director of curation. Bob originally worked with us, but he retired on April, and Troy Luck is now currently taking over as the CTO. So what is the problem? Phoenix Bioinformatics has a tool called TOAST, which stands for TARE Online Annotation Submission Tool. This allows researchers to be able to submit their annotations for their research paper. And the current TOAST at the moment, there are issues with it because it's difficult to maintain and it uses older technology. Also, there are some usability shortcomings because it had an unintuitive workflow and interface. Also, Phoenix Bioinformatics wishes to extend the system instead of for just Arabidopsis thaliana. They wish for it to accept other genetic information from other organisms. And also, the curation is done on a separate tool when this should be done on the same system as TARE.
So, now that we've established what the problem is, what were the requirements that our sponsor gave us to work with? Well, first and foremost, we were required to make a system that would support a workflow, a new workflow, for researchers to submit annotations, as well as a workflow for curators to be able to revise these annotations, since the existing tool didn't do so already. We were also required that the system be able to integrate with ORCID. ORCID is an external system used by researchers as a means of identifying themselves. They make an account in ORCID, and then that's how they can be traced back or sourced. And this makes our system easier to use for them because that way they don't have to make a new account, rather they use an existing one, which shortens the amount of work that they have to do. We're also required to have our system integrate with various external resources, and from these we gather things like lists of ontology keywords, which for our purposes are the keywords used to describe genes in their annotations, as well as resources that would help us gather the gene loci. And loci is the plural of locus, a gene locus being any given sequence of genes. So given this data that we have to work with, we also were tasked with consequently making a new schema database schema that could account for the representations of this data as well as the workflows that it has to undergo now. Another important requirement that we were given was that the system be able to export data. And this is primarily so that a curator, if they need, be able to download the data and work with it offline if there is any need. And finally, we were also required that this system deploy to Amazon Web Services because this was the server that we were provided to deploy to. So with that said and done, let's talk about the submission workflow. Consider a researcher that wants to annotate a publication. They would go to the GOAT system, where then they'd be prompted to log into their ORCID account so that we may authenticate who they are. Then they will be prompted to identify the publication that they wish to annotate, as well as the gene loci that they wish to annotate. And then they would select the appropriate ontology keywords to describe these genes. Then they would just submit the annotations. The system would take care of validating that this information was valid. For example, making sure that they submitted an actual existing gene ID. And if all successful, they've just submitted an annotation. So then we consider, all right, what is the curator's workflow? It starts off similarly with the curator logging into their ORCID account. But then as a curator, they're able to access a view that has a table listing recently submitted annotations that they can then select to view. These they can then decide to approve as a valid annotation, reject, or if only some changes are needed, they may choose to edit the annotation. Once they've done so, the annotation is just marked as accepted or rejected, but no longer pending for curation.
All right, so how does our GOAT system address these issues? So the main parts we implemented were the client and server boxes you see there. Everything else is systems we had to integrate. As you saw in the requirements, there was a lot of integration we had to deal with. So one of our sponsors' main requirements was to use more modern web technologies. So we implemented a JavaScript front end with React and a RESTful Node API on the back end. This is a very common pattern in modern web applications. So going into our integrations here, we have to integrate with 3 ontology resources, and these are where the keywords come from. If you remember during our last demo, in the interim, we showed the import pipeline for that. Those are the gene ontology, the evidence code ontology, and the plant ontology that we have to integrate with for this. We then have to integrate with locus sources, and this is where we validate lookups for the gene identifiers that were given in annotations. For that, we integrated with RNA Central, TER, the resource that's managed by our sponsor, and Uniprot. And finally, we had to also verify publication IDs. And for those, if you're familiar with any research publications, 2 standard ways of identifying those are PubMed IDs and DOIs. So we integrated with PubMed.gov for verifying PubMed IDs and DOI.org for verifying DOI identifiers. Finally, we needed to integrate with the taxonomy database for verifying genes and mapping them to other species. If you remember, the previous system only dealt with Arabidopsis thaliana. This allows us to map genes to all other organisms, which is something our sponsor desired.
So let's do a demo. I'm going to have Joe walk through the submission workflow, and I'll explain what's happening at each step of the process.
I don't know. Okay, there we go.
All right, here we go. So this is our homepage. This is our app deployed on AWS right now. Let's go ahead and log in. So you see, when we click login, it brings us right to the ORCID site. The margins project here. This is where researchers could create a new ORCID account if they don't have one already, or log into an existing one. So let's go ahead and do that. So you see in our upper right-hand corner there, Joe is logged in now. If he extends that box there, we see that's his ORCID ID that will be associated with every submission he makes. When a user first signs into our system, they are automatically treated as a researcher, and being a researcher, they have access to the submission page. So let's go there now. This is the page where researchers can associate genes and annotations with a single publication. Now, as we mentioned, a publication can either have a DOI ID or a PubMed ID. This one up here is a PubMed ID. Now, I don't actually know what's in that paper, but for the sake of the demo, let's pretend I wrote it, and let's pretend it references 2 other genes. The first one is going to be this AT1G 10,000 gene, and I want you to remember what this page looks like, because I'm going to talk about this later. Let's go ahead and paste that in there. But AT1G 10,000, that doesn't really roll off the tongue all that well. So we've got researchers can optionally specify a symbol or a full name as an alias for a gene that they're talking about. So let's add another gene, and this one will come from Uniprot instead. And we don't have to come up with a symbol or a full name for this one. That ID is short enough. And when we click out of this box here, you'll notice it validates for a second. We do a little bit of pattern matching on these IDs. You'll notice the AT1G and the D7L5 one, they're a little bit different from each other, and we can do some pattern matching on those to figure out what database they come from. And then we can take a reasonable guess at which database we should look at first. And that can drastically speed up our verification process there. So let's add an annotation now. You'll see the default annotation type is molecular function, and that maps a gene to an ontology keyword. And by default, it references the first gene. Now, we talked about in our midterm presentation our keyword import pipeline. This is where we use those keywords in our system. So if we start typing, say, beta-am, we can see it gives us a couple of suggestions related to what we've just typed in. So let's just pick the first one. If we type that same beta-am in this other method box here, you'll notice no results come up. And that's because we filter keywords by which box you're typing into. Each keyword has a separate type. So let's have another annotation now. And we'll change the type of this one. Those first 5 there all relate genes to keywords, but the 6th one, protein interaction, relates genes to other genes. So we can relate our TARE gene to our UniProt gene and have an evidence keyword as well. So let's add a final annotation. And we'll make this one a comment annotation. And this is just a free-form text entry box to describe something about one of the genes in your submission. So I think that'll about do it for our submission. Let's go ahead and submit that. And you see it says submitting there for a second. That sends all the data to our server, which validates all the genes, just double checking that everything exists, and make sure all the keywords are in the right place. And now when we click back here, it clears the page out, so if the researcher has a second submission they want to create, they're all set to go with a blank slate here. But this account Joe is logged into is also marked as a curator, which means we have access to view every submission that exists in our system right now. Let's go there now. The default sort here is by date created, descending. So the submission we just created will be the top one on the list there. But if we're looking for something else, we can change the sort on these. We can change the date ascending. We can sort by the number of annotations present in the submission. And we can sort by the ID of the publication referenced in the submission. That's about it for our demo. So let's talk about some challenges that we ran into with our project. The biggest one for us definitely was the domain knowledge. I don't know about the rest of you, but the last time I saw biology, it was in my freshman year of high school. I thought I was done with biology. I was wrong. And that leads into our data model as well. There was lots of terminology that we just weren't familiar with in our system. So we ended up having to maintain a small dictionary of terms, just so we always knew what we were talking about. And that bled into our data model a little bit. Because we were so focused on making sure the data model accurately represented the data that our sponsor was interested in, that we didn't stop and think about the technical implications of representing the data the way we were. So a few times we would have to pause the stories we were working on and redo our schema a little bit to support the new feature. Integration with external systems. We also mentioned this one during the midterm presentation, but this one came back again. This is a twofold problem. You remember a few minutes ago I said, remember what that page looked like with all the information on it? Well, that's important because every source we integrate with has different information and just as much information. So we had to work with our sponsor to make sure we were always talking about the right information from each source. And the technical problem we ran into, that's the twofold part, that's every one of these sources has a different API with varying levels of documentation quality. And some of them just didn't have documentation at all. And the ones that did, sometimes the documentation was wrong, and sometimes the data was just in a weird format. Finally, project scoping and estimation, which just ties into the top 3. We would think, say, integrating with ORCID would be a one-day affair. A week later, we're still working on it.
So what went well during our presentation was that this semester we decided to use Zoo.io, which is a project tracker that integrates very well with GitHub. It's essentially a Kanban board where we also have our backlog, so we could easily assign different stories to team members. And also, our sponsor can also view this, so they can actually see our progress and see how things are going along. And with our sponsor, we have meetings that are productive and frequent. Every week we have a Skype meeting where we discuss our concerns or go over anything we've done. And any other concerns or questions that they have, we did it through email. And also we sometimes have more meetings if it's necessary. And we did a good job on understanding our domain because it's so unfamiliar with us. And this really helped on our documentation and implementing the software, and also for making the schema, which is pretty much the basis of our project. And also, we have an extensive unit testing infrastructure that was well documented. It basically serves as a documentation for our system's functionality.
So what's in store for the future of GOAT? Well, the sponsor definitely wants the open source project to continue being worked on. They've actually expressed interest in having a future team pick up where we left off and continue our work. As you saw during the demo, the full curation functionality is not yet implemented. The ability to edit individual submissions is not yet there. And our sponsor also wants some improvements on searching. They want, one, users that are not logged in to be able to go onto the system and search through annotations and view things that have been approved. And also the keyword matching you saw during the submission process, they'd like some improvements on how that works as well. They would also want to be able to export the data that's submitted to a standard format. And we feel like we've done a good job setting this project up for future developers. We have extensive documentation in the GitHub wiki right on the individual repos themselves. So any developers interested in contributing to the project can look directly at that and learn about all the different parts of the system and how they work together. Additionally, thanks to Zoob, all of our issues and stories are tracked through GitHub. So they can see the history of everything we've done, details on how we did it, and also see the issues we haven't gotten to yet. Just some final remarks. We feel like we learned a lot from this project. We definitely got a lot of technical knowledge and engineering experience, a lot of exposure into exploring a new domain that we were unfamiliar with. It really sort of enforced just how important domain analysis is firsthand. We also feel like we addressed the more challenging technical problems during our work on this project. So the system integration that we mentioned earlier and that base data design that sort of leverages everything else in the system. Our sponsors seemed really happy with our progress, and they expressed that they had a really good experience working with us, as we did with them. And we'd also like to give a special thanks to our coach, Bill, for all his help and guidance, and our sponsor team for working with us and really being patient with us as we try to understand this unfamiliar domain. And with that, if anybody has any questions, feel free to ask them now.
Did your product sponsor have any requirements for specific browsers that they wanted you to use? Did you want to not as good ones for the product?
Yes, so they told us pretty much modern browsers. They mentioned Chrome and Firefox. So there was at one point where we had one issue where an event handler was not working properly in Firefox. We fixed that in a weekend, so we were grateful to be able to deal with just modern browsers when implementing this, which is really nice. Yes?
So you have a feature where you auto-identify a gene, select a gene based on its identifier, you search through multiple databases.
Yes. So
Was there ever concern where you might have selected a gene that had the same identifier? There's multiple genes with the same identifier, and was that ever brought up in your design discussion?
A gene should never have the same identifier. Well, that's more of a name than an identifier. We use that sort of interchangeably, but whatever ID you type in, there should only ever be one gene that has that name.
Okay, so when you search multiple databases, you select the right one automatically.
Well, there should never be a collision. The format of IDs in different databases is fairly different. Like, for example, the TARE database, all of their genes talk about the Arabidopsis thaliana, so they start with AT. RNA Central was another database we worked with, and all of their IDs start with URS, followed by a string of zeros. And for Uniprot, there was a little less of a format there, but there's no collisions that we're aware of.
that initial matching we do to determine which resource to check first only gives us a hint on which one to check first. So if we don't find it there, we do fall back to the other ones.
All right. Hello, everyone. We are the Tax Efficient Retirement Income Team. I'm Ryan. This is Phil, Jordan, and Derek. And first off, we'd like to thank our faculty coach, Professor Reckelmeyer, for helping us out this entire year, as well as our sponsors, Mark Seiler and Steve Howells. And so today, we're going to talk about the problem that they wanted us to solve, some of the non-functional requirements they had, and then we'll go into our solutions, starting with our system architecture. Then we'll talk about the settings that the system has, and then the different accounts that can be entered into the system, and finish with our savings and spending algorithms that we created. And then we'll go into a demo and finish up with lessons learned and future work for the project. And so Belziani is our sponsor, and they are a financial planning company in Rochester. And basically the problem at a high level that they wanted us to solve was projecting for retirement of their clients. And not only just given a client's assets and their income information to project it out and see how long it's going to last, but also optimize that so that it'll last the maximum number of years and pay the least amount in taxes. And so they had some existing solutions to this problem. The first was an Excel sheet, and it did the job of projecting, but an Excel sheet is really unmanageable in this problem, because once you get into the complex tax calculations, the formulas and stuff become really complicated beyond the basic tax brackets. And then they also had a commercial financial planning tool which allowed them to enter in all the client information and the account information, and even select the order that they withdraw from the accounts, but it didn't give them the fine-grained control to withdraw from the accounts around certain tax brackets. And that's really what we implemented. And the non-functional requirements weren't very constrictive for us, so we were able to focus on the problem a lot more. We had minimal security requirements because the application's hosted on their local network, so no one can access it outside of their company. And there's also no sensitive information in it anyway, so there's no social security numbers, and names can even be changed if needed. So if it even was compromised, none of the client information would be at risk. And there's also a low number of concurrent users because it's only used within their company. And they also had low performance requirements around the algorithms, and they said that if it took 5 minutes to run, that would be okay. And so we didn't really need to worry about optimizing it too much. We just really wanted it to work and solve the problem. And so our system architecture is really just a simple web application. We have static files hosted on an Apache server. We had a React and Redux front end, and it's just the bundled HTML, JavaScript, and CSS that gets served from that server. And it also acts as a reverse proxy to our Java application backend. And that is just a simple REST API hosted on a Jetty server that's bundled in a jar file. So to run the entire backend server, it's just as simple as running a jar file. And that saves all the data to a SQLite database. And that's our entire architecture.
So now on to the features of our product. So most of the project is extremely dependent on tax calculations that come from the 1040 form. And this is based on the tax code, which is subject to change in future years. So our sponsors stress that it's important for them to be able to change any values to be able to still use the product if the tax code changes. So we have a settings page in the UI where you can change things like the tax brackets, capital gains. You can change inflation based on what the inflation is for each year. And you can also modify certain tables like contribution limits, withdrawal limits, and minimum distributions for accounts. So there are different types of accounts that you can invest in for retirement. And there's two major categories, and those are qualified and unqualified accounts. Qualified accounts have special tax treatments, while unqualified accounts don't. So an unqualified account would be your savings account or your brokerage accounts. And these accounts, you pay taxes on the income in the year that you contribute the money, and then you pay taxes again when you withdraw on the growth as capital gains. And then for qualified accounts, there's tax deferred and tax advantage accounts. So tax deferred accounts are like 401ks and IRAs, where you don't have to pay the tax up front, but you have to pay all the tax when you withdraw as income. And then for tax-advantaged accounts like your Roth IRAs, you pay all the tax up front, but then all of the growth is tax-free. And we found that the order and amount of which you withdraw from each account makes a significant difference in the amount of taxes that you pay in the long run and how long the money lasts.
So in order to generate projections and optimize accounts, we have a few different algorithms. Our algorithms are split into savings and spending. The savings algorithms are going to come into play when the clients haven't yet retired, so they're still adding to their retirement accounts. Savings algorithms are split into two subsets. The first is the basic algorithm, and all the basic does is use values that are configured by the user. So the user has the option to input different annual contributions that are being made to each account, and the basic algorithm will just project that out based on things like account growth value and inflation. The next one that we did was the native prioritizations. So essentially what that's going to do is it's just going to prioritize which account the money goes into. It gets the amount of money that the user has by getting the difference between their desired income and their earned income. So if they're earning more than they desire, then all the rest goes into the accounts as we specified here. So the different letters stand for the different accounts. So QRU would be prioritizing the qualified, and then the Roth, and then the unqualified. And how that's going to work is it will contribute all the money into the qualified up to the legal annual limit, and then what's left of that will go to the Roth up to that legal annual limit, and anything that's left will go into unqualified. Because the qualified and the Roths both have annual limits, the only one that we have that you can put all of your money into is the unqualified. There's no limit there, so if a user wanted to, they could have all of their money go into unqualified accounts. So after the savings are done, we have a couple different spending algorithms. The first one is going to be the basic. This is going to be the most similar to the naive prioritizations on the savings algorithms. So what that's going to do is it's only going to pull from one account at a time, and it's going to start out with the 401k and IRA, then go to the Roth, and then go to the unqualified. So it'll just drain each account until that one's empty. The next option that we have is reverse. This is kind of more of a proof of concept. It shows some contrast from the basic, but it's typically not going to be optimal. And then the last that we have is the tax bracket optimized. So tax bracket optimization works by trying to stay below a certain tax bracket. So if a client wanted to stay below like the $75,000 tax bracket, for example, but they wanted to have an income of $100,000, you could still do that by taking $75,000 from a qualified account. So something like a 401k or an IRA, you can take 75 from that, and that will be your taxable income for the year. And then you can get the remainder from something like a Roth account, which isn't going to count towards your annual income. So in doing so, you would stay below the $75,000 tax bracket, but still be able to have $100,000 in your actual usable income.
All right, so now we're going to do a demo. All right, so this is the application, the first screen you come to. It just has a list of all the clients that have already been entered into the system. So if a client came back into them and they wanted to play with some numbers, they could easily do that and not have to re-enter all the information just by going to one of these. We're going to start by creating a new client. And so it basically takes you into this creation wizard. So we have to give it a name. And then we have to give it a filing status. They can either be single or married. In both cases, in a married case, you need to add 2 people to the account, and the single is just 1. And then enter their desired income. We'll do $80,000 since it's right around that tax bracket. And then we have 3 fields for itemized deduction. And basically, the pre-retirement, mid-retirement, and post-retirement, they all map to different time windows. So for a married couple, the pre-retirement is when they're both currently working. And then the mid-retirement is when one person's still working and one has retired, and post is when they've both retired. Then in cases where you have a single person or they retire in the same year, the mid-retirement itemized deduction will just be ignored. And then if you enter a number less than the standard deduction, the system will just opt to use the standard deduction because that's how the tax code works. And then we'll also enter the inflation rate and submit that, and then it takes you to create a person. And so on the person page, you would add the first person, and then you need to know their birth date so that you're able to project what their retirement year is. So the 1970, and then you can see the Social Security year and pension year, they automatically filled into what the retirement year would be. But you can go in and change that to a different year if they don't start receiving Social Security or their pension on the year that they're retiring. And then you can also change the retirement age around, and it will automatically update those fields as well. So we'll give them a Social Security benefit of $10,000 and give them an earned income of $50,000. So this is essentially like the first person's salary. And we submit that, and then we have to enter the details for the second person. And then again, it autofills all the stuff, and we'll give them a Social Security of $8,000 and set their earned income to $50,000 as well. And so once we created the people for the client account, we now have to enter their account information. So the first account we'll create is a 401k for the first person. And so each account has to have an owner because if you retire before your partner, you can only withdraw from your 401k or IRA or Roth account. And so we create a 401k, current principal, put $400,000 because it's roughly what someone would have if they were born in 1970. A growth rate of 2, contribute $10,000 per year, and employer contribution of 5%. So we submit that, and then we can add another account. We'll add a Roth account. And then the Roth accounts have a much lower contribution limit than the 401ks do, so this principal wouldn't be as high. 200,000, 2%, say they contribute 5,000 a year. And then finally we'll add a shared unqualified account. And we can assign the second person that. It doesn't really matter who owns that because there's no restrictions around the unqualified accounts. And this one. So now we've created the accounts, and you could of course create more, but for the sake of the demo we're not going to. So you click done, and we're done with the wizard, and it immediately takes you to that client page where it shows all the details that we just entered. And so from here you can edit any of the information, and you can also add more accounts, and then we'll go into the projections. And so on the projections, the first screen you get is this giant table, and the table basically shows all the numbers that have been generated by the selected algorithms. So we'll start with the basic ones, and basically the reason we need a table is so that if the financial planners wanted to dig into the numbers and actually see what's going on, they can easily do that. But if we wanted a more big picture view, we can go to the chart, and then the chart has a couple different views in itself. So the first thing we see is an income statement, and so the income statement shows basically where that person's money is coming from. And so you can see in the first few years here it's blue, and if we look at the key, that's their earned income. And then this first year with different colors is their first year of retirement, and it's red and green, and the red is the 401k and the green is the Social Security. And so because it's the basic algorithm, it's just going to pull from the 401k and then the Roth and then the unqualified accounts. And then if we choose a different algorithm that so for this example, it doesn't really change very much. And then if we look at the tax proportion, we can see The green is like the amount in taxes, and the orange is the contributions. And so for the basic savings algorithm, it's just using the contributions that we entered for the client. And so these blue bars are lower than the ones in retirement because they're actually contributing so much that they're digging into their desired income in those years. And if we switch to a different savings algorithm, you can see the orange doesn't really dig in and they meet their desired income there. And then you can also look at the different information for the account. So we can look at the account balances, and then you can also look at the withdrawals in the different years and so on and so forth. And then finally there's a summary page. And this page basically runs all the projections for all the different combinations of algorithms and then gets the data for the total amount paid in taxes and the year that the money runs out. So you can easily see that some combinations of algorithms last longer than others, and some pay less in taxes. So the financial planner can come to this page to clearly see what algorithms work best for a certain client, and then they can go back into the projections page and look at those combinations of algorithms to get an idea for what is best for that person.
All right, so lessons learned. We learned quite a bit as we did this project. One thing that really stuck out to us is that we should have embraced automated testing early on. Early on, our domain architecture wasn't exactly what it needed to be in terms of knowing everything it needed to know. And that was kind of an issue because as we learned more about what it would need to do, we learned that we needed to recreate this architecture and kind of start over from scratch. Not completely, but partially. And as a result, a lot of our functionality that we had at that point, it didn't actually work. So in order to test all of that again, we had to re-put in all of our information manually, and that was kind of a huge pain, which would have been a lot easier if we had some automated testing. The second thing is we should have taken advantage of all of JIRA's functionality. We got that early on set up, but we only took advantage of some of the features, such as like the prioritization and assigning tasks and stuff like that. But it does have formal bug tracking, which we should have used, but we just didn't end up using that. Another thing is, as I mentioned with the automated testing, we should have explored the domain early on to make sure we had a full grasp on exactly what we needed to do. Just because as we talked with the sponsor more, we learned that we missed some things early on. And because we missed those things, we had to start over and recode some things, and that was kind of a pain. Future work for teams that work on this in the future, or anyone who does pick it up, something that would be nice is to generate printable reports. Right now, the only thing we have is those stats pages and the graphs and stuff like that, but there's no printable report that you can generate for the customers, which would be really nice if you could show them how their money's lasting and how each of these algorithms makes a difference. Another thing that needs to be done is we need to implement algorithms that aren't naive. Right now we're just prioritizing around the tax brackets, so if you're going to make around whatever that tax bracket limit is, we start pulling from different accounts. There might be better ways to do that to make your money last longer. We haven't implemented those yet, so that's a next step for someone else who works on this. And what kind of ties in with that is we need to be able to support Roth conversions. That will improve these algorithms and who knows, maybe make the money last a little bit longer. And finally, we need to be able to give some more configuration power to the people running it, just because right now, for example, there's no way to set different desired incomes for different windows of time. Finances are always changing. In the future, you might know that you're not going to need as much money as you need right now, but there's no way to do that right now in the application. So it would be nice if we could set that up so there's a little bit more configuration power, and when they're doing that, they can create better reports for the future. Any questions?
Yeah.
I'm curious about the algorithms you're using. Were those provided to you by the sponsor, or are those things you had to come up with? Is that standard in the financial planning industry?
Yeah, so that's pretty much what they came to us with at the beginning of the year was, for the most part, people generally just withdraw from their qualified accounts, their 401k and IRA, then the Roth, then the unqualified. And they basically theorized that If we withdraw and stay around this, like the tax bracket threshold around a person's desired income, so that their taxable income is below that, then we could probably make it last a little longer. And the reason for that is because right around, like, for a married couple, the $75,000 tax bracket is 15%, and then as soon as you go over that, it jumps to 25%. And so by playing with, like, your withdrawal so that you're keeping your taxable under that, you're not paying 25% on whatever's over that, so it helps in the long run.
So that you created, you came up with and tested out those theories, or
Yes.
the sponsor said, try doing it this way, this way, this way, and you saw what was best?
Yeah, so we implemented, like, that idea, and then that's pretty much where we ended, like, this semester with, was we have, like, first and second and third tax brackets, and you can kind of see around the, like, if their desired income is around those tax brackets, then, like, it does make a difference. I actually screwed up the demo and gave them too much Social Security money, so their desired income was met with just one account and the Social Security. But if I can show you for a second. So if we go into this example, you can see right here how the pink is the 401k, and so it's withdrawing the 401k up to this threshold here, and then it's supplementing with a Roth and an unqualified account, and basically that right there is the tax bracket limit. And if we look at the summary for these people, you can see that so the qualified one is the one that generally lasts the longest for the savings algorithm, and then second bracket and third bracket, they're paying significantly less in taxes each time, and they all last to 2078. But if we look at the right here, and then we look at the different algorithms, you can see in the final year right here, on second bracket it's the highest. So basically in their last year, they have the most money, like, with that algorithm. So it's not like a great example that shows a huge change, but it does make a difference. Yeah.
So you said in the beginning that you had a very high time limit for algorithms to run.
Yeah.
Do you think that gave you a lot of freedom in how you were designing it? Like, if you didn't have that high limit, would you have changed the way you designed the algorithms?
Oh, yeah, so because of that, we didn't really have to have any considerations as to how long they would take. It did turn out that because of the way the algorithms work right now, where they're kind of simple, they actually don't take that long to run. But in the future, as more algorithms that take a lot more power, as those are needed, that might become an issue where time comes into play. But like you said earlier, because there's no real constraints, that's okay, and those algorithms can take longer. But just because our algorithms are kind of simple right now, they're pretty quick. I mean, as you saw when he pulled up that stat page, which does run all those algorithms, it took less than a second to pull that up. So there's really no issue there.
The register better.
So in the beginning you said that you were using SQLite for your database. Can you explain that choice, given it seems like your data is going to be very large as the system is used more and more?
So the data that we store in the database is really only the client information, so anything you see on this page. Any of the projection data doesn't get stored, as that's generated every single time you make that request. And we don't think that this data alone would be, like, even if you had 100 clients in the system or more than that, like, it won't tax the SQLite database too much. Sorry, I'll go to you next. Professor Hocker.
Talked about non-functional requirements. Communicated that the requirements were rather low.
Yeah.
But if you look at the usability, I have trouble understanding those graphs, for example. For usability, I think would be a high priority non-functional requirement.
Yeah.
In particular, modifiability to be able to change the algorithms. I think is important. So from an algorithm change point of view, how did you separate that concern out so it could be changed easily?
Do you mean switching between the algorithms in the view, or changing how the algorithms work?
Changing how the algorithms work. You said one of your first future goals was non-naive algorithms.
Yeah.
How would I change those?
So currently there's no way to do it through the front end. You would have to write an algorithm in our code base, and we use the strategy pattern. So the algorithms implement a certain set of functions, and to create a new algorithm, you would just create a new class that is part of that strategy pattern that implements those functions.
Okay, thank you.
Let's thank the team.
All right, hi, I'm Sam.
I'm Alton.
And I'm Jeremy, and we are a team toward force. And before we get started, we'd just like to thank our faculty coach, Dr. Valeno, for his continued support throughout the project, as well as our sponsors, John, David, and Wally. It was really a blessing having sponsors who were not only technically literate, but also very available and responsive throughout the project as well. So thank you to all you. Moving on. So our sponsors association is the Adventure Cycling Association, the ACA. And what they do, they've been around since the 70s. They have over 50,000 members. They have their own magazine. They are responsible for advocating for better bicycling conditions throughout the country. They also host over 100 annual guided tours. And our mission to help these guys out this year was to get them into the mobile arena. We're augmenting an application from the previous year's senior project team called the Bicycle Touring Companion, which was available on Android. So we not only augmented that application, but we also delivered iOS and web versions as well. So yeah, moving on. So yeah, the BTC, what it's really going to help the ACA with in their mission overall It's going to help them expand and branch out, and it really, the overarching goal is to help users. The main target audience will be traveling bicyclists and tourists, or sorry, not tourists, just bicyclists throughout the country, plan and research and navigate routes. So, yeah, so one of the things that the application really highlights is the ability to crowdsource service-related information. So one of the things that you can do, the app that stands out from a lot of other applications on the market at the moment, you can plot points of interest, such as services and alerts. So be it a hotel, a restaurant, or a cliff as an alert. So yeah. So the state of the bicycle touring companion and how we received it in the beginning of the fall, it was sort of bare bones. It was sort of in an alpha release kind of a state. Some of the features that were included in it include the ability to view services and alerts on the map. Not everything was complete, so this is where the augmenting part comes in. So for example, the filtering services and alerts, add and update service information. You could also publish and sync new content, and there are some offline features as well, which is important because as a cyclist, you're not always going to have great reception wherever you're going. Some of the things that we brought to the table this year with the BTC include an iOS and web version. That's the main non-functional sort of requirement that we wanted to get done this year. Cordova really helped us a lot with that, and Sam will talk about that in a little bit. So we also designed and built a reset password flow, which didn't exist before, so if you forgot your password, you're sort of out of luck in the application we received. We built a point flagging system to allow for moderation, so there are a lot of trolls out there. Some people are a little malicious, so if people post bad content, we want to have the ability to moderate that and get it removed if necessary. So we also designed and built an onboarding experience to help new users, and this is important because as much as we'd like to claim that we are usability experts, there are a few parts of the application that might not be incredibly intuitive to everybody. So if you're a new user, when you start the application, you'll have these onboarding panels, as you'll see in the demo, that will help you get accustomed to how to interact with the app. We also have camera capabilities, so the ability to upload and capture pictures and attach them to services and alerts. This isn't a core functional feature, but it definitely helps polish the application. So when you view a service, if you want to have more light shedded upon it, then you can see what it looks like and stuff. If it's a restaurant or whatever. You can also center the map on your current location, which is important because if you're trying to plan and research a route to navigate, and it's not where you are currently, it's helpful to be able to recenter the map on your current location without having to zoom out and repan the map. Another thing that we did, we integrated the mapping layer with OpenCycleMap, which is sort of the premier mapping technology that's out there right now. We've added the ability to comment on and rate services, which again is sort of just a polishing feature, but it's very helpful to have. You can auto-publish services and alerts. This is important because as a user of this application, you might be on the bike riding sometimes, and we don't want people to put themselves in danger, so it's good that you can have less interaction in order to publish stuff. For example, before when we got the app, if you wanted to publish a point to the server, such as an alert or a service, you would have to manually go into the drawer in the UI and then publish it like that. But now if you're offline and you plot a point, it'll automatically publish as soon as you come online. We also simplified and improved the USBRS route screen. USBRS is a type of route that exists in the application, which we'll see in the demo. We improved documentation for smoother maintenance and future handoffs. So this is really important because in the beginning of the year, the state of the application that we got, the documentation was a little spread thin and a little obscure. So it'll be easier for future teams to sort of pick up and get off the ground running easier next year. We also investigated custom vector mapping solution, and now we're going to go into the demo.
Right. So now that Jeremy has kind of talked about all of the features that we've added, we wanted to go ahead and show you just kind of what some of those look like. So the first thing that new users will see, we're just going to reset the app here, is these onboarding panels. So as he had said, not every feature is completely clear, so we wanted to give users the ability to kind of read up and kind of understand how to use the app, basically. So here you can see, this is how you can create alerts to warn users of maybe the road is being flooded or being retarred or whatnot. So once we see these onboarding panels, the next thing that users will see is the map. So this is what users will see anytime after that first time, whenever they open up the map, is this. Now this will be seen whether or not you're logged in or not, so that was one thing we focused on. So you can zoom and pan and look around the country and view these different alerts and services that we can kind of see here as the blue points. So if we click on one, we can see this one is Love & Cup, and we can see more information about it. So we can read the phone number, the website, some of the amenities, along with the hours and availability. So some restaurants would all obviously be applicable to bike riders, but also bike shops and other services like that. So we can also view the ratings. So let's click on that. And this was, the view was there as of last semester, but not the functionality. So we've gone ahead and added that. So now we can type up a comment and add a rating. And now one thing you'll notice when you hit submit is we're redirected to that login screen, because while any user can view and look around the map, when you want to contribute by adding alerts or updating alerts or adding a rating, that's when you'll need to log in. So now you'll see you have this nice logged in message. So now we're logged in, so now we can add an update and actually kind of contribute to the app. So let's add a new point. We're right here in the Liberal Arts Hall, so let's add a point here. And this is a service. So we worked a lot. The adding the service was pretty much done last semester, but not everything worked. It wasn't finished. Another thing we also worked on was upload photo, as Jeremy had talked about earlier. So we'll go ahead and upload a photo. Now this is currently being run on the on an iPad here, but it will work completely the same way on an Android app, any iOS app, or even on a website as a web app. So he went ahead and just added a photo. That was done through the camera device of the camera, which is a feature we added this year, but you can also upload from the device storage. So there you see it's already auto-published. Since we have an internet connection, if we didn't and we were in the middle of nowhere, then it would be saved in the published drawer and uploaded as soon as you came back into internet connectivity. So the next thing we wanted to show you was a USB-RS routes screen. Again, this was started last semester, but there were a lot of buttons and some things that were there but didn't actually work. So we wanted to make sure everything that you see on the app is actually functional. So this United States Bike Route 20, we can click on Show Route, and that just jumps to that route right there. So this goes right across Michigan, and you can see, you can plan out your route, all of the alerts and services along that route. So if we clicked on that, this park here in Michigan, one of the things, since the data is crowdsourced, we want to be able to bring issues to the admin's attention, so we added the ability to flag points and services. When you flag a point, it's brought up to the moderator's attention, and if something is flagged by 3 different users, it'll automatically be hidden until the admin goes in and checks what's up, and they can go from there.
All right. Thanks, Lester. So let's go back to Keynote. All right, so let's talk a bit about our architecture. So one of the things that we appreciated from last year's team was that they actually did a pretty solid job designing an architecture that would work for us. Some of the implementation details we had to iron out as we went to hit mostly our non-functional requirements, but they pretty much handed us what we have here. So the 2 top layers there, the 2 top boxes are layers that we have on Amazon Web Services. So we have the CouchDB database system that's really useful for offline syncing and kind of resolving kind of merge conflicts, because when you have a need for offline and a need for syncing, things get really extra complicated pretty quickly. So that can actually has a write-only or a read-only connection from the client to that. So the client directly replicates all of the point information from CouchDB for it to be able to use offline. So that's one of the things like Austin and Jeremy were saying. It's really important that if you're in the middle of like Montana or something, and you have no cell service, that you're still able to use this. And that's one of the key competitive advantages we have over some like app like Yelp or whatever, or your average mapping application. So the application server there on the top left is able to write to that. It also handles our authentication issues. So one of the key changes that we had to make this year was splitting out the photos to load on demand while everything else replicates. So when we inherited it, it was copying everything down from Couch on the first launch, and that was incredibly unsustainable. It would copy every point in the world and the photos that didn't have a size limit. So we needed to do a bunch of things like size limiting the photos that are uploaded in the first place and downloading those photos on demand, because it's completely unreasonable for you to have a copy of every photo for every point in the world copied to every user's phone. But it does have all the point information, so that's there if you are somewhere and you need to know some information that was downloaded to your phone. So our client app, like we've mentioned, uses a Cordova wrapper around a JavaScript app. So Cordova, if you're not familiar with it, provides a native wrapper around some kind of web app. So our web app is using Node, React, and Redux. Pretty much none of us had experience with any of these technologies going into this year, but it was very important for our sponsor not to just throw away everything that the team did last year. Because while a lot of stuff was prototyped, there was actually a pretty solid foundation there. So that was one of the first things that he said. He wanted that, and he wanted regular software delivery, which I'll talk about more in a minute. So we were able to adapt ourselves to the app rather than the app to ourselves. And I think that worked pretty well, but we'll talk about that more in the reflection. So we did switch our mapping service to OpenCycleMap. That's software as a service. It was OpenStreetMap when we inherited the application. And OpenCycleMap is just using the data that's available from OpenStreetMap, which includes a lot more than what OpenStreetMap includes in its service by default. OpenStreetMap has a ton of data, including like power lines, railroads, and stuff like that. But that's not important for a bicyclist. It's more terrain and the bicycle information. So we're using that at the moment, and we did explore about halfway through the year running our own map server. And while that wasn't as high of a priority, we did prove that we can actually download the data ourselves from OpenStreetMap and design our own maps using this map CSS technology and kind of an open source tile server project to avoid some licensing fees involved with OpenCycleMap once this team or the next team was able to add offline use of tiles, because OpenCycleMap requires a licensing fee for that. And then you can see we have a shared model repository that we use between the client and the server to maintain model integrity. Couch really does next to no work for maintaining the integrity of your models. Okay, so like I mentioned before, one of our biggest accomplishments in our process was that we delivered consistent usable builds. We have 19 usable builds that we've delivered to the sponsor at this point, and it will be hopefully 20 by Monday. And that means that we delivered a build every week and a half. This was a significant change over the team last year, where he only saw a lot of demos and didn't have working software in his hands. And that's one of the main reasons why we chose feature-driven development. It provided us the framework to do that kind of continuous feature-based delivery to the sponsor without having too much process getting in the way, because our sponsor really just wanted working software over documentation or anything like that. The documentation goes along with the software in the form of our build log. We actually have a 15-page single-spaced build log at this point for everything that we've done the whole semester, and we have the documentation as we're working through in GitHub. And that plays into our code review process as well. We had a self-imposed mandatory code review process on every commit that went into the app. So this helped to avoid the issue of knowledge siloing, because we did choose features based on like, oh, Austin did a lot with auto-publishing the points. It makes sense for him to do this next thing. But while that's great for productivity and he can be really knowledgeable in that area, we tried to fight against that to balance the yin and the yang of that by using this code review process. So we thought our meetings went pretty well. We didn't meet if we didn't need to, and we only communicated what we need to the sponsor. We called out meetings on a decently regular basis. And Jeremy being remote as well this semester didn't hinder us at all, because our sponsor is actually not in the room right now. He's watching from Montana, and so we were already used to that process of working remotely, and that added an interesting dimension, but it didn't cause any hindrance to our process. So the product, we think we accomplished some pretty good work. We got what he wanted and more. Sometimes the direction would change, but we he told us he was pretty happy with the product. And it's in a much more handoff ready state where our sponsor, John Adventure Cycling, can start to actually do some more internal testing and actually have people install this on their phone. Because earlier this year when we inherited the app, for example, if you opened it on some versions of Android, you would just get a white screen with no explanation, and the crash was actually pretty tough to find wrapped in all those layers. Because, for example, like a certain version of Android didn't have something in ES6 that needed to be shimmed still. So it's stuff like that that we had to do for stability and scalability that were big improvements as well. And like we mentioned, there are no more stubbed or prototype parts left, and we can, or John can release it to a wider audience. So our final slide, what's next? So the sponsor is planning to request another team for next year. I think that request is already in. That'll be a senior project team. That'll be the third team to work on this. And that internal testing, adding more USB-RS routes to that screen, that's actually just pretty much a JSON list that they can add to with some metadata. Downloading routes, having that offline capability, the team last year did somewhat work on that, but it was built around their system, which wasn't as sustainable as the mapping system that we've built up here. Custom vector maps would be a great win for branding, bandwidth, and storage, and just keep working on that scalability and stability work. All right, so with that, here we go. Do we have questions?
Yes.
So you showed when you attempted an action that requires you to log in that
Yeah.
are you logging in? Do you still maintain the action they were trying to perform? Or did I attempt to review, get asked to sign in and then the review disappeared?
Yeah, that's true. We don't support that yet, no. Yes.
So I know you mentioned you don't cache all the photos offline. Have you thought about, I guess I have no idea how big your points database ends up being, but if this is a massively used system, are there concerns about even downloading all of the point and point information to each phone? Is that potentially a problem as well?
So scalability on the back end, we actually have our two layers, our couch database layer and our server are behind elastic load balancers on AWS. And they're both theoretically, you could set them up to have another instance. For financial reasons right now, it's a nonprofit, we're trying not to spend a lot of money. We only have one server behind each one. But with Couch, you can spin up a second one and set them to auto-replicate to each other so that you could scale this to any amount. Yeah, you could do some caching on the client if you wanted to hit the servers less anyway, just for performance, but it's ready to be scaled.
Well, you said you do cache on the client already. You cache all of your point data, but not the photos.
That's correct. I was talking about the photos, yeah. If you wanted to cache the photos, but the entire point database, the text in that, and the coordinates and everything like that, that is cached. Yeah, everything before you just see that photo lazy load in is all cached on the client.
So are you concerned about that point database becoming too large and having?
Oh no, not really for the text. No, it hasn't been. We've tested it with a decent number of points. Nothing like crazy at this point, but the size of it, from what we've seen, isn't insane. Without any, there's nothing. We don't have anything else other than photos that would be like a data blob. There's nothing. It's all text. Mm-hmm. Yeah, Malta.
How much space do you actually anticipate that will take up on the device? Are we talking about a gigabyte here? Are we talking about, if there are instances where apps become unusable because their memory hog, they use too much space and you just can't have that on your device?
Yeah, I mean, that's unknowable. We haven't done specific stress testing. I guess we could multiply out some smaller sample. But we could see it when there were photos that were replicating. Like that, we hit that at some time in the year when we had photos in there. We said, like, no, we have to take these out. And since then, even on the initial replication, which is the biggest one, right? It kind of works like a version control system. It'll take everything initially, and then it'll take diffs on top of that. So for bandwidth, it should be okay. But once we split out the photos, we didn't see any problems practically. We have probably about 100 points in there, maybe shorter than that. Probably about 100 points in the system at this point. But I don't have a number for storage now. We do have a capability of storing the database outside of the web browsing engine, because that can be a problem that you hit pretty low limits on web storage. But Cordova provides us a mechanism to write that out to the native app storage if we needed to store more space. But obviously we wouldn't want to be a data hog, but I don't think we would be.
All right, let's thank the team.
All right, everybody. We are Team Reactive Healthcare. We worked on the Laboratory Information System Interface with Ortho Clinical Diagnostics. We'll give you a brief introduction of the team. I'm Connor. This is Sam, Yi, and Jeffrey. Our sponsors are Ken Staffen and Jim Prozorski, and our coach is Larry Kaiser. Thanks for being here today, guys. So to give you a brief overview of our domain, it kind of starts off with a laboratory technician or a doctor communicating with an LIS, which is a laboratory information system. This laboratory information system communicates via the chemistry analyzer, which is this Vitros 5600 integrated system on the right, which has an LCI panel screen on top of it, which is a laboratory computer interface. So this basically communicates with the laboratory information system, sending an HL7, health level 7, kind of a messaging protocol, test order to the LCI, which then responds and sends a test result back. Now this laboratory computer interface kind of is the background for what we had to work on primarily. It basically houses all the background for what we had to do for our specific project, where it receives test orders and returns results. The problem with the current domain is that the communication between the LCI and the LIS is only half duplex right now, as well as the chemistry analyzers from different vendors are not as interoperable as is ideal. There are a couple of different profiles that could be implemented to adhere for more interoperability. So these stemmed our requirements given to us from our sponsors. The first is being a full duplex communication. The second is that profile, another profile that could be adhered to increase interoperability. And then the third being a FAR implementation, which is a RESTful web-based API for sending HL7 messages. This was a stretch goal, or at least announced to us at the very beginning of the project, that we diminished pretty quickly because of the complexity of the first two requirements. So let's get into the requirements for the full duplex communication. So half duplex is when one system is trying to send to another system and it is unable to receive at the same time it is sending. So when this laboratory information system sends a test order to the LCI, it is unable to, at that moment, to receive a result at the same time. So the major improvement that could be set in place is that while it is sending a test order, it's able to receive concurrently at the same time. So we're going to get into our design, and Sam is going to go over the duplication of the layers that we've implemented.
So in order to have simultaneous inbound and outbound communication, we decided to duplicate certain layers of the existing communication model. The session, data link, and physical layers were duplicated, and each channel, so to speak, was given the responsibilities of either receiving messages only or sending them only. So the benefit of doing it like this is, first of all of the layers already communicate concurrently. There's an existing IPC framework for communicating between layers. So by duplicating them, we can make use of that existing framework still to communicate with the other layers. And also by splitting the responsibilities of the different channels, but not the actual functionality itself, we're able to have the two different channels working simultaneously for full duplex and still supporting half duplex with just a single channel. A couple of challenges that we experienced with this design. First of all, the system was designed with 4 layers hard-coded in, so we needed to abstract out a lot of references so that way we can have duplicates of layers without references being mixed up. There were also some shared memory issues. If one layer had a static reference, for example, duplicating that layer, they would both be trying to update that variable. And then also, just by nature of increasing the number of simultaneous processes that are running, it increases the complexity to test and debug the system. And now Connor will talk about the listening socket.
So the listening socket starts up in the LCI manager, which is a certain class within the code base. Now basically what it has to do initially is it has to create these layer message queues to be able to send messages between each one of the layers. And then once you create each one of those queues, it then needs to go and create a thread for each one of those layers. And once those 2 things are initialized, then it'll open up the channel and the queue connections to kind of connect those 2. Now this is how it existed before we touched it. Once we duplicated the system, it then increased the 2 channels for the inbound as well as the outbound. Stemming off of this is how we designed our listening socket. Once the channel and queue connections are in place, the LCI manager then sends an event to start listening on the physical inbound layer thread, right? So as soon as it receives that event, it then creates another listening socket thread, which within that thread creates a socket, binds the address in the port, and then begins listening. So let's take a look at the creating of the listening socket thread and the design of that. So the LCI manager layer thread, what it does is it comes down and creates a thread for each one of the OSI layers that are present on the system. What we initially tried to do is we tried to create a thread off of the physical layer thread because most of our functionality exists within the physical layer thread. Well, we had a couple of problems that it was a little challenging to create everything for the listening socket thread because the initialization of the physical layer was not complete. So what we had to do, and what we ended up with in our final design, is creating that thread off of the LCI manager layer thread. This properly waits until layer initialization by decoupling the thread creation as well as removing a little bit of the dependency on the physical layer. And as you can see, it's much cleaner and does not increase the depth of the threads present. So once this listening socket layer is kind of in place, we had to actually implement a multi-threaded server. It wasn't required by us, by our sponsors, but we approached this and thought it would be a better idea to include the addition of a multi-threaded server for our listening socket. So what we did here is we have multiple clients on the left, and each one of those clients can be thought of as an LIS. Now, when an LIS tries to connect to our listening socket, which is our server, the server then accepts that client and then spawns a handling thread to kind of increase the interoperability for it. And so the thread then kind of processes all the messages on that server. So if we look at kind of the advantages and disadvantages of this full design, we can see that the socket handler threads avoid interruption and blocking on the system, and we're also able to support multiple client connections because we include the addition of these socket handler threads to process each one of these messages. And then finally, we also include dynamic thread creation. Instead of choosing a thread pool as our design, we wanted to kind of create threads as needed so that we can kind of theoretically use any number of threads and there could be any number of client connections possible. Now, some of the disadvantages that immediately result from choosing that pathway is that we have to keep track of all the open connections. Prove it by the following testing and validation workflow. So we first start up the LCI in full duplex mode. Once we do that, we use Lua itself to kind of create a Lua socket instance. Once we have that Lua socket instance set up, then we connect to the LCI, to the listening socket. Once we're connected, then we send an HL7 test order through the Lua socket. We make sure and confirm that then HL7 test order is present in the database and it's been uploaded as a sample. And then what we do at the end is we make sure that we can send messages from both directions simultaneously, being able to throttle the messages being sent so that we can make sure they're being sent concurrently. So we did not present a demo to you today because we didn't deem it as valuable. A lot of the stuff that our project was implemented was in the back end, so you would kind of only really see it as a connection terminal. So we're kind of just showing you as it looks in the final product. You can see that we didn't actually do too much, at least changing to the GUI itself. So this is the LCI manager that a laboratory technician would be seeing on a chemistry analyzer. They would first click the options button, go into the configure the communication, configure the LIS, and then finally this is where our changes were amended. We included the addition of an HL7 full duplex mode, and then also the ability to specify the port number that you wanted the listening socket server listening on. So now we're going to go to our second requirement, and he's going to talk about that.
Okay. The second requirement of a project is IHE law profile support. By supporting IHE law profile, analyzers from different vendors can communicate directly without the need of middleware or customer device drivers. It reduces the complexity related to the analyzer and the analyzer managers. And law profile covers the workflow called analytical work order steps, AWS for short, between the analyzers and the analyzer manager. This workflow handles the processing of IVD processing by the analyzers. The virtual analyzer currently supporting HL7 2.5, and the IHE law profile based on 2.5.1. So for supporting IHE law profile, the system should be upgraded to HL7 2.5.1. Law profile is a standard which has a amount of use cases. In our project, we are focusing on 3 use cases. Query for AWS broadcast, and AWS status change. Order Manager is an application from Gazelle platform, which is open source test bed dedicated to interoperability and conformance testing of e-health system. It's a simulator for various actors from different domains like eye care, radiology, and laboratory orders. We are handling the laboratory domain in our project. Using the Order Manager helps us to test the transmission of the messages between analyzers and analyzer managers, such like sending and receiving query of the AWS and other use cases. Order Manager exchange message with IHE law standard. So mean it not only work on auto analyzers but also work on other analyzers which support IHE law standards. HR7 editor is a part of the Gazelle platform dedicated to the validation of HR7. The engine is based on the API library. For each received and sent message, we can test the simulator to validate the message with HR7 validator. The application gathers the HR7 conformance profile and HR7 tables. Then the HR7 messages are validation against HR7 by HR7 conformance profile.
Okay. So we built a virtual machine in collaboration with our project sponsors, and it contains the software that you just described. In particular, the Order Manager and the HL7 Validator are useful for us in validating the IHE law profile. There are some things we like about this virtual machine in that we can save our work offline, and we can continue to work in case of any server outages or setting changes or things like that. We're also able to configure our virtual machine specifically to our analyzer, so as we're prototyping and as we're developing, there might be some settings that we need to turn on or off in order to get things working for the time being. Then we have the unique ability to kind of monitor the simulated laboratory information system, which is really key in our productivity, because it lets us get a perspective on the server side and kind of what's being received and what needs to be tested further. There are some downfalls, though, to kind of working with this virtual machine and things we want to improve, which are particularly the ability to keep this virtual machine up to date. There are a lot of software changes that are made as the standard becomes more fine-tuned and things are more brought together for the industry as a whole, and as people come and develop new analyzers, they can provide feedback, and the IHE community can develop for that. Another particular thing that we are finding challenging sometimes is we can't really develop conveniently on our laptops running multiple virtual machines. So sometimes you have to work at a desk and keep working. Some of the more granular challenges that we've had are just this lots of tweaking and lots of setting changes have created many versions of virtual machines we're trying to test and get working. And we're still finding challenges and technical difficulties with regards to getting some of these virtual machines working. So we've switched over to targeting directly the IHE servers, but there's this added risk of losing connectivity to them. And we've actually experienced a large major change that midway year during the interim session that caused some problems that we had to address. Okay, so this is a actor and use case diagram. This is directly from the final text of the IHE law standard. You can see there's featured two actors, the analyzer manager, which represents the simulated analyzer, and the analyzer at the bottom of the screen represents the emulated analyzer running on our host machines. There are three major transactions that are being addressed in this diagram, and I'll go briefly through each one. There's query for AWOS, and this could be considered as a request for patient work orders or a request for patient samples to be done. Once this request is made and acknowledged, the analyzer manager will then send or transmit the patient work orders to the analyzer, which the analyzer then has the opportunity to either accept or deny those options. And then once the analyzer receives that patient test, it can go on and run the results, run the test features, and transmit those back to the analyzer manager. All of this functionality has been built into Ortho's products already. We're validating the conformity of this functionality against the IHE profile. So we have a working understanding of how all these use cases work, and we've been able to then take that understanding and devise testing and experimental scripts and steps. We can take to test each one of these use cases. And we've been able to successfully test the first use case of our project, but the other two use cases have been challenged due to technical issues and lack of experience so far as we know the system exists.
With the help of the Gazelle test platform and the application therein, we can test the transmission of the message with ease. All of the tools are from the Gazelle platform. That means we can avoid the compatibility problem. However, Gazelle platform is an unfamiliar territory for us. It took quite a while for learning, configuring, and using the tools. We underestimated the time that the tools required. Once established, the Gazelle tool can help developer to test any use case of IHE law. In the future, the tool can be used to validate the message in different analyzers and to test the HLC message of version 3 or higher.
So just in summary, these were a couple of areas that we experienced in this project. All of us came in with little or no actual exposure to any of these areas, such as multi-threaded programming, network programming, state machine design, outside of the classroom setting. So we gained a lot from this project in all of these areas. And as a reflection, some positive things. Full duplex is working. I say in theory because we have been testing using manual tests. IHE law test case 27 passes. The unit tests for full duplex are all designed, and also code reviews for each commit ensured that everyone had a knowledge of the code and also prevented any bugs from being committed, hopefully. Some negatives, we had some technical issues, especially towards the end, which have prevented us from being able to use our unit tests. And same with IHE law, technical issues have prevented us from being able to test 28 and 29. So for the future, all of our work has been done on virtual machines, on our own personal computers. So before this can be deployed, it needs to be tested in the field on actual analyzers in a laboratory setting. In addition to the 3 use cases for the IHE law profile, there are many other use cases outside the scope of our project that will also need to be tested in order to comply with that profile. As we mentioned before, fire was a stretch goal and we were unable to implement it. So in the future, that would be a great thing to add to allow for RESTful web APIs for sending HL7 messages. And finally, there were a couple of changes that we made to the GUI, as you saw in those screenshots. Those were mostly for our convenience, so in the future, the changes that we made will need to be more integrated in the GUI. And now we'd like to open it up to questions.
So towards the end there, you mentioned that technical issues block you from testing a couple specific test cases and from, I think you said, from running your unit test. So how long has that been a problem? Like, have you ever successfully run your unit test? Do you know the current state of your project?
Sure. So we use Lua to test our project. One of the components to test that is Lua socket. There has been a couple of test cases that we've devised that use netcat in particular. It doesn't give as much control over the actual socket programming within your Lua test script. So we've been attempting to use Lua socket. There's been some conflicts with at least our virtual machine and our specific version that we have. It may be because we're using a virtual machine, we're not sure. We've been trying to address that right now. So we have some tests working with netcat, but we want to primarily work with it with Lua socket to kind of give us more control for kind of throttling the full duplex tests that really require that kind of control.
But so at least through netcat, you know that your tests can run?
Yes, they can run. They just don't provide the same amount of control.
And for Lua, if we want to bring in a new technology or a new add-on, you have to bring it up from the ground up and kind of compile it and import it in. Lua is very bare bones and doesn't really have all the details there for us.
You guys mentioned that you were only able to test on virtual machines on your local machine. What kind of conflicts or problems do you anticipate that might come up once this is kind of deployed to the real analyzers?
Sure. Yeah. So the real analyzers are giant. I'm not sure the exact dimensions of it, but that's why it's a little unreal for us to go, or at least have our own. If you can say, you can kind of think of it taking up like at least the size of that table over there, if not a little more. So primarily for testing it in the field, since we have different versions of stuff on our very VMs, some of the software could be of different versions. So there could be some complications there with different versions of that. That's something that I can at least think of right now. I'm not sure anybody else has anything to address with that.
So when it comes to IHE law and testing the conformity of that profile, there is a big convention that they have called the Connectathon, and that's where people can bring in and integrate their systems at a more real level. And so the challenge there is kind of seeing, are we conforming in the real world situation, not just the simulated environment that we've been testing with. So that's also a concern and can be addressed at the Connectathon when you're working with real engineers or other engineers working on real products.
Any other questions?
Let's thank the team.
Thank you very much.
Hi, everyone. We're the BAT team, and for the past 8 months, we've been developing an app for the business action tracker for our sponsor, Lockheed Martin. My name is Shade Nofsiger. This is Alex Perrell, Chris Jones, Corbin Mayu, and Adam McCarthy. And before we begin, we'd like to take a brief moment to say hey and thanks to our sponsors, Jamie and Ellie from Lockheed Martin. They proved invaluable for us during our conversations weekly. So thank you for being here. Now I'm going to hand it off to Alex, who's going to talk about the problem our application is designed to solve.
Before we do that, I'm going to give a bit of background information on Lockheed Martin. They are the world's largest defense contractor, and they have 120,000 people worldwide employed to them. Our sponsors in particular are from the Enterprise Business Services Division, which is in charge of making software for the day-to-day business operations of Lockheed Martin. One thing that you might not know about Lockheed Martin is that they are a matrix organization, which means that one person, one employee is not exclusively assigned one project. One employee might be working on several different projects at the same time, and this factors into our problem in our design. So for this presentation, let's pretend that I am a Lockheed Martin employee and that I am assigned to 5 different projects, one of which I manage. On these projects, I am assigned various action items, which are tasks that I am responsible for completing. The issue with this is that across all 5 of my teams have different ways of tracking these action items. For some teams, they might use a paper to-do list. For some teams, you might have an Excel spreadsheet that's being passed around via email. And some teams might use different software systems in order to handle this. This causes a couple of issues. For one, I don't have a centralized place that I can view all of my tasks for all of my projects that I'm personally responsible for. I might not be able to get a list of my actions when I'm out of the office. I might not be able to efficiently track our team's progress, and my higher-ups cannot do cross-project metrics because of the fragmentation of systems that are in place.
So to solve these issues, our team has created an intranet web application for tracking these action items. Using it, Alex, our lovely employee here, can view and update all of the action items assigned to him across all of his projects. He can also effectively manage his own project, even on his company phone when he's out of the office. In our scenario here, Alex just got out of a meeting. In the meeting, they decided that Corbin needs to update some software on the image processing system for his UAV project. With our solution, this is quick and easy. First, Alex navigates to the website in his browser. Because the site uses Active Directory to authenticate users based on their Windows domain accounts, Alex doesn't have to fill out a registration or a login form. He's already signed in. Alex will create a new action for this and add some details to it. In the meeting, the team decided that the updates need to happen by next Friday at 5 p.m. Alex doesn't know that date offhand, but he can just enter next Friday, 5 p.m., and the system will handle the rest. Alex will put this action on the UAV project and assign it to Corbin. At this point, Alex could add additional details, like a priority, a parent action, or mark that the action is blocked by something external. Satisfied with what he's entered, Alex can now save the action. To help Corbin with his work, Alex needs to share the software update procedures. He can just upload this attachment and store it alongside the action. When Corbin starts work on the action later on, he can download the attachment to help him out. During the meeting, Adam reminded the team that he's going to be taking vacation for the next week. Isn't that lovely? As the project manager, Alex needs to reassign Adam's most important action to a different teammate. Alex can navigate to the projects he manages and find his cloud operations project. He can open the security audit action item and quickly reassign it to Shade. When he's done, Shade will get an email informing him of this change. The last part of the meeting was introducing a new member to the Cloud Operations project. Chris, welcome aboard. To allow Chris to see the project's actions, Alex will edit the project and add Chris as a member. Optionally, he could make Chris an additional project manager, but for now he'll just be a standard user. With the end of the workday approaching, Alex is getting ready to leave. Before he leaves, he checks his list for personal actions, which are actions only he can see and aren't associated with a project. After sending an email to Corbin about the Memorial Day party, he marks his action as complete, and he can save this action and head home, completing our demo. At this point, Alex will go into some more detail about the system itself.
All right. So this is a diagram of our architecture and some of the technologies that we use. As with any web application, our architecture is divided into two parts, the front end and the back end. The back end code is written in C# and uses the Web API framework. It connects to a SQL Server database and exposes a REST API, which is consumed by the client, which is an AngularJS single-page application that runs across most major browsers. The way these two sides communicate is via the OData protocol, which specifies how the backend should export their models and their responses, and also provides operations on working with the data on the server. As for why we went with a website, one benefit is that a website is centralized. The single source of truth for a website is the backend server, unlike, say, if you were passing around Excel spreadsheets, you might have multiple users editing the same sheet, but on their local computers, causing conflicts. When we're using a website, the backend server is the only source of data, so it's always correct. This style of application with a REST backend and a single-page front end is fairly common in the industry now, and in particular, our sponsors at Lockheed Martin have had several projects using this general architecture and these set of tools, so that we're confident that they'll be able to maintain and extend the system after the semester ends. One last thing to note is that by using a standardized protocol, Lockheed Martin can integrate other clients to the backend server, such as a phone app in the future or some reporting tools of theirs that communicate via OData.
So what makes this system the best fit for Lockheed Martin? Well, first, we've specifically designed the system with respect to Lockheed Martin's matrix organization structure. We've designed projects in our system to be very lightweight because we anticipate that people will be a part of many different projects through their day-to-day activities. Additionally, we've consolidated features of the existing tools in use at Lockheed Martin so that our system is generic enough to be helpful to all teams at Lockheed Martin. This means that if you're a member of multiple projects, you only have to use this one system and you don't lose any functionality. Finally, using a well-established specification, specifically OData, allows our system to be used with other tools, like Alex mentioned some reporting and analytics tools that Lockheed Martin uses. And it also means that we can extend the system, or Lockheed Martin can extend the system in the future with relative ease.
So now that our specific involvement with the project is coming to a close, we'd like to give a general overview of what will come next for the project. We will be handing off just about everything that we have related to the project to Lockheed Martin in order for them to continue development. One thing this includes is a very detailed and prioritized product backlog. From the very beginning, we knew that we would not be able to complete everything within the entire scope of the project. However, we still went ahead and created many detailed user stories and a prioritized list of features. Throughout the project, we continuously reprioritized items according to feedback. Handing off the product backlog will allow Lockheed Martin to pick up right where they left off and continue development according to their own specifications. We will also be handing off the deployment scripts and guides on how to set them up, guides for setting up the development environments, any design diagrams and all of the documentation we have, and of course the entire code base itself.
So no project can happen without its fair share of challenges and missteps along the way, and ours was not an exception. We would like to highlight a few of these challenges and talk about the lessons that we learned from them. First up has to do with our process. So from the at the beginning of the project, we decided it was a really good candidate for Agile, and our sponsor was very familiar with Agile process, and they requested that we use one. So we decided that we would use Scrum, but we recognized that due to our academic obligations and our academic schedule, everything in pure Scrum didn't really align with what we needed. So we made some adjustments and documented them accordingly. The first one being that we did hold daily weekday stand-ups every morning at 10 a.m., but those were now remote over Slack because of just our schedules and when we could meet. And whereas a normal work week in Scrum is your standard 5 days, 40 hours a week, we recognize that our schedules are much less consistent. So to handle that, we scheduled and assigned tasks during sprint planning based on hourly capacity per day. And finally, due to our small team size, the product owner and Scrum Master did code development as well. And so the big thing that we learned and the takeaway from this was that sometimes following a process purely as it's prescribed might not be the best fit for your project, and you might have to make some adjustments and document them due to your constraints.
Another big issue that we had in the first semester was that initially our sponsors had expressed interest in developing this as a SharePoint add-in. And this is the design that we went with for 10 weeks into semester 1 until when we were talking with a member of Lockheed Martin's IT team, they notified us that SharePoint add-ins were not allowed at Lockheed Martin due to security concerns. So this was a very big architectural change for us, and we decided that this constituted a sprint terminating event where we stop all of our tasks for the sprint, and instead we investigated other approaches moving forward and presented them to the sponsor, which led to the architecture that we have now. We learned several things from this. First of all, we were thankful that Scrum had some process for dealing with this large of a change, and we felt that we were able to handle that change fairly well. But ultimately, this issue came around because we didn't fully research the environment that we were going to deploy this into, and we also left out a major stakeholder in our program, specifically the IT group. We've kind of felt that this is a limitation of Scrum. In a plan-based process, stakeholder identification is an explicit step as part of the planning phase, but with Scrum, it's assumed that the customer is the major stakeholder.
So another lesson learned involved the API testing that we had running against the project. Using a tool called REST-Sharp, we created API tests alongside the development of the features that they were testing. During the initial phase of the project, we came to the decision that we would not seed test data into the database, or that the test would even directly touch the database for that matter. Also, due to the nature of how our system authenticates using your Windows account, and how the API tests run directly through Visual Studio, we were only able to run these tests under a single user account. This ended up creating issues when it came to testing specific features, such as assigning actions to other users. So if you were going to assign an action to another user, there would be no way for the API test to log in as a different user and test to see that that action was assigned to that user. Instead, we ended up having to do manual testing of the API through a different user account in order to work around this issue. Looking back, we could have made some different or better decisions on how we could approach testing in order to avoid these issues we ran into. For example, we could have considered using seed data or directly querying the database to ensure that data was correct. This all ties into the idea of being able to design from the beginning with testing in mind.
Another lesson that we learned throughout the course of our work here is that early on, our sponsors wanted us to use, indicated they wanted us to build our project to the OData specification, which we talked about a little bit earlier. It's a specific format for REST APIs that allows for programmatic exploration and interoperability with other systems. None of our team members were at all familiar with OData when we started this project, so there was a bit of a risk there. But what we determined that we should do some research and figure out a little bit about this specification and some of the tools for interacting with it. We eventually settled on two frameworks, Breeze and Microsoft Web API, which made our implementation of the specification a lot easier because they handle a lot of the work for us. The two frameworks really helped us to write less code and made it a lot easier to implement many of the features that we ended up supporting. From this, we learned that with any standard framework or set of tools that you're going to pick up and use, it can take a while to become familiar with that technology, so there's definitely some startup costs associated with it. But we also found that in the long run, the benefits of using these specifications and tools often outweigh the costs because it ends up being easier to add new features, it becomes easier to tie into other systems. But of course, there are shortcomings of any specification, and OData is no exception to that. It was difficult to implement some of the features that weren't directly supported by the specification, specifically things like multiple user profiles and uploading file attachments were kind of tough to work around the specification. But we felt that in the long run, it was a benefit.
So this concludes our senior project presentation about the Business Action Tracker. We'd like to once again thank our sponsors, Jamie and Ellie, for being here today and for all the support that they provided throughout the entire project. We'd also like to thank our coach, Professor Malachowski, for all of his support. And now we'd like to open up the floor to any questions you guys may have.
Yeah, so you talked about the SharePoint add-in and how you have to go back and rework the product there. How long did that take to, I guess, to rework all the work you've done in those first 10 weeks? And
So,
then as a result of that, did you then have to go back and maybe identify more stakeholders or more things in the design that need to be changed as a result of that?
so how long did it take to rework the SharePoint issue?
Yeah.
As far as identifying all the other options, it didn't take very long, in particular because the IT person that we were talking to thankfully had some guidance on what Lockheed Martin was familiar with regard to other projects. So we had a bit of a direction over what they're used to working with and what they supported. It did take a while to get started in learning the new framework, but I think ultimately the solution we went with was better in the long run. Another reason was because the reason we were talking to IT in the first place was that we were having a lot of issues trying to set up a local SharePoint server, and so changing architectures also cleared up a roadblock with that.
How long did you guys spend on your sprint? How long did we spend on Sprint Zero?
So our Sprint Zero, I guess, or our startup in the first semester was the length of a regular sprint about. So we spent about 2 weeks getting people's environments set up and debugging and just general development environment set up. I'd say about 2 weeks. And then from there we started to flesh out our backlog, and starting with Sprint 1, we were exploring some of the features.
How useful did you find daily stand-up in academic environments? Actually curious.
So how useful were daily stand-ups?
So I actually thought they were pretty useful, not necessarily for figuring out what people are working on, but a lot of times people would say, like, I don't have anything to work on today. And even in situations where they didn't expect to have free time, but they ended up having more free time than they did in the sprint. There were a lot of situations like that where people were able to pick up work from other people who were maybe a little bit overloaded with other coursework and things like that. So I actually thought it was really helpful to have those daily stand-ups.
I can also say from a testing point of view, it was very nice to be able to see how things were progressing, and then to be able to kind of brace yourself before you were going to dive right into the testing.
Is
system like this, I can see a lot of information being generated with any functionality added or thought given to like a high-level view for managers where they can roll up the information.
So high-level view for managers?
So, as was mentioned, we are passing off quite a backlog of additional features we'd love to add. But one of the tools that Lockheed Martin already uses is called Tableau. It's a reporting tool, and that already has integrations for OData compliant tools. So we are somewhat depending on their existing reporting tools, so that they don't have to learn yet another reporting tool just to extract data out of this. So we've built it to spec so that it can work with these external tools. That being said, we do also have some features in our backlog going forward for adding some kind of metrics and analysis for more of a project manager or administrative view.
Anything else?
Let's thank the team.
Hi guys, we're the automated functional sizing team, and we're going to be talking to you about our sizing project. I'm Zach. This is Eric, Alex, and Eric. So just to introduce the scope, our sponsor is Lee Fishman of Gallerath Incorporated.
Galarath makes software called SEER software that estimates effort and duration of projects. Through their estimations, they've discovered that project size is pretty well correlated with effort. You can see from this chart that plots functions against productivity that there is a pretty positive slope between effort and project size. One way of measuring project size is through functional sizing, which is basically using function points to scope out meaningful areas in your project where you're going to be putting the most effort forward. This sizing method is used to size projects that haven't already been built, and that size is then used to estimate the effort that it's going to take to build that project. Our sponsor's goal was to be able to use the methods of functional sizing on existing projects using a project source code, and then we'd be able to compare what we're going to build to projects that have already been built. Just a quick overview of how functional sizing works in its current form. When you're given a list of requirements, you want to identify and count the function points in those requirements. And usually these points are going to be where the user is going to be interacting with the system. So you count up these points, and then you use these points to help you identify the internal and external structures that your project is going to have to use. You put these components into a formula, and you get a functional size. So this is a pretty expensive and difficult process. Usually you rely on professionals to do it, which obviously costs a pretty penny. So automating the process can have a lot of benefits. So like I said, our sponsor wanted us to be able to run this project on some source code. This would help mostly because of the fact that a lot of companies are going to have source code more readily available than the requirements for the projects that they've done in the past. And also source code is a lot better representation of the final project than requirements because it is the final project. So I'm just going to run through our approach. We're using abstract syntax trees to represent the source code. That makes reading source code a lot easier and faster. We're generating an AST and then analyzing it. Luckily, the generating step is done by a third-party tool called Antler that we've used very extensively. So all we have to worry about is actually analyzing the tree. Our initial approach was to map the ASTs to a theoretical sizing framework that our sponsor kind of mapped out for us. It involves answering several questions about each of the functions that we identify. Is the function self-contained? Where's the boundary between functions? And is outside data updated by the function? Basically, what this framework is doing is helping you to identify the internal structures in your project. The first semester was mostly spent researching our domain and formulating our plan. We were all very unfamiliar with the domain, and so we had to spend a lot of time getting familiar with it. This period was marked by a schedule of coming up with a list of questions with our sponsor to make sure that we were kind of going down the right path, and then going and doing our own research as much as we possibly could, coming back and discussing what we found. Some of the questions that we were trying to answer: can we work with multiple languages? How do we deal with external libraries? And how do we answer those questions posed by that theoretical model? Probably the most important question. One of the major issues that we ran into was that the ASTs were very large and complex, and so we needed a way to simplify them. So we spent a significant amount of time developing a way to convert the AST to an intermediate model, which we could customize to more fit our functional sizing needs, and that ended up being a lot easier to parse. So what we ended up focusing on, the theoretical model that we started with ended up being a bit too difficult to implement. We were making way too many assumptions about inputs and outputs in the code, or I'm sorry, way too many assumptions about the questions that we would have to answer to fill out the theoretical model. So we ended up focusing mostly on data transactions consisting of inputs and outputs. Our approach was to break down states and methods in classes into inputs, outputs, or neither, and then use those to help identify the internal structures that we'd have to deal with. Unfortunately, external structures in this approach would be a bit too difficult to identify, so we didn't end up actually finding a way to do that.
So the second semester mostly consisted of using our intermediate model and analyzing it to find the inputs and outputs that we wanted to find. Major issues that we needed to account for in this semester: how do we account for the methods in external libraries? And we also wanted to allow the user to mark methods in their source code as inputs and outputs to help us come up with a more accurate functional size. Halfway through this semester, our sponsor realized that getting a functional size wasn't going to be as helpful as providing the user with the metrics to come up with a functional size. We were making a lot of assumptions with the metrics, and so we figured that it would help a lot more for someone doing functional sizing to go in with the metrics that we provide for them and do the calculations themselves.
All right, so before we get to actually doing the demonstration, we just want to discuss the architecture really quickly. So our architecture is split into two basic sections: the pre-compilation and the runtime. So Antler actually doesn't run when our project is running. The way Antler works is we feed it a grammar, whichever grammar file we want, and that specifies the syntax of the program that we're running. And that grammar we used, since we targeted Java 7, was a Java 7 grammar that can be found on GitHub as an open source file. So we feed that into Antler, and it creates us the parser, the lexer, and an API to work with, so that we can actually walk those ASTs more easily. So we would extend that API to what we needed in order to create the internal model. So when our code runs, our code actually takes the source code and parses it using those files that Antler gave us. And then we use the API that we modified to create the internal model that we would then utilize later to come up with our functional metric output. So the functional size analyzing portion of our program would use these inputted library files that we'll show you later. And those library files would allow us to analyze those inputs and outputs and other state information and create this functional metric output that the user would then be able to use to come up with a function point sizing or however they wanted to use that information.
All right, so before we get too far into the demo, I just want to say that visually speaking, we don't have a whole lot to show for two reasons. The first reason is that our system was heavily focused on the back-end development, and the second reason is that our sponsor wanted a command line tool. So with that in mind, we developed two additional tools, the creation tool and the creation UI, which I'll go into more depth in the next couple slides. And Eric and I will be walking you through a step-by-step guide on how a user would utilize our system. So first, the user needs to produce a library file for any external libraries that they would be using. So this tackles that first issue that Zach had brought up previously, where we need some information on these external libraries. The creation tool basically contains information on the structure of the external library, along with marking up each method as an input or an output. Now, you just need to run. So we're only going to be running this over a very small subset of the Java standard library, just two classes, the buffered input stream and buffered output stream. So to use it, and he has already run it, okay. So to use it, you simply specify where you'd like the output and where the source is, running on the size of jar. So as you can see, the library file contains the classes, the package information, along with inheritance information, and the subsequent methods and their return types. Now, as is, this only gives us information into the structure, and now we need information on inputs and outputs, which brings us to our next tool, the creation UI. Now, these library files can be extremely large when running it over an actual full library. So we needed a simple way for the user to go in and annotate these files. So running this is simple, running the size of jar with the edit flag, and it brings up the UI. And you load up the library file, it populates the panel with the information. And all of the methods. Now, say we wanted to modify the read methods as inputs. Simply mark the radials, save it, and it will modify the library file. And same thing with writes, mark them as outputs. And when you save, it simply marks the methods as with There we go. With just a simple I for input, O for output. And now our system understands what is an input and what is an output within the external library. Now, for demo purposes, we just ran it on the Java standard library, but realistically, if you were using, say, something like Spring, you would need to run it over Spring and then annotate it yourself. And this would be for any external libraries that you would be using in your source code. So now that we have the library file, we can move on to the bulk of our system, which is the source code analysis. Now, this is what fulfills our requirement. Now, the library file that we just created is incomplete, so we won't be using it. We will only be using the built-in library file for the Java standard library that we have built and fully annotated, and we'll be running our system on a program called Polster that Eric has written. Basically a simple web-based polling app written entirely using the Java standard library. And so you give it, you run the size of jar, the size flag, specify where the project is, specify where the output is. There's a couple other options that you can include, like a log file to get a view into the system. The include option specifies the location of all the library files that you would be including, but we don't need that right now. So we run it, and it spits out this frankly unreadable information in the console, but if we move back to the presentation or just open up the CSV file, we get the metrics that our sponsor had requested. Number of files, number of classes, states, methods per file, inputs, outputs, and the GUI inputs and GUI outputs was something specific that he wanted. Basically, inputs and outputs presented to the user in the UI. And finally, possible ILFs or internal logic files, basically a file that is specifically meant to hold state. We basically set a rule that would, if a file held more than the threshold of states, we'd mark it as a possible ILF to let them know, go in and check it out.
All right, and so some of the technologies that we leverage, we use Java as our development language, and we use IntelliJ as our IDE. We use GitHub for configuration management and also working with each other to do code reviews and things like that, since GitHub has all that built in. We use Maven to help build as well as to handle our dependencies. And we use Antler, as we described before, to make it so we didn't have to write our own parser, which would need its own slew of unit tests and would probably spend half of our time trying to write that if we didn't have Antler.
So now we'll get into the current status and the future work.
My bad. So some of the deliverables that we were handing off to our sponsor, the size of jar executable and the research paper, those were the two most important. Obviously the executable and the actual work, but the research paper was as important, if not more. He was really more interested in the path that we took to get to our approach, the reasons we did our approach, the way we did it, as well as any drawbacks that we might have had. So he was really pushing to make sure that we had that. That way, if he decides to go and present this somewhere or talk about it more or move forward with it, he would know exactly why we did what we did. So our project status, we're able to parse, interpret, and output metrics on Java 7 and older projects. We can allow for extensions to our application through those library files that we mentioned before. We're able to run on large projects, 5,000 plus files in less than a minute. So even though there's a lot going on in the back end, we're able to move through it pretty quickly without holding it up. And the research paper, like I mentioned before, it helped capture all the facets of the project from the conception to the research along with the development. We also included some final thoughts at the end and the conclusions on the project for, maybe where it would go from here.
So now I'm going to talk about a bit of some of the difficulties with our project, some of the drawbacks of our approach, and alternative approaches that could be used in the future. So really the main difficulty, to wrap things up, is that functional sizing is generally a human process. You look at the requirements of a project, and it's usually done before a project starts. And with that, there's usually a lot of sizing to infer about the project, and it requires a lot of previous experience for an estimator. So to give an example, one of the first projects that we sent to our project sponsor was a tiny board game project. We wanted to use a project that was written all in standard Java. And this was in an effort to get an idea into our sponsor's head about how he would take a project and size it, so to check that we were mapping our automation to the ideas that he had in his head. So looking at this project, it's a tiny board game project. He was able to infer that there was a board that would maintain internal state, and there are players in the game that will be making moves, and those will be considered the inputs and outputs to the project. So with inferring that there is a board game, he was able to infer that there was internal state, and he could group that data together as an ILF, which then ILFs could be used to contribute to a functional size. So that was one of our first indications that there's a big human element into the sizing process, and that last step of grouping the data together into ILFs would be a bit hard for the automation process. It's really hard to guess the boundary of the application and then determine inputs and outputs in order to functionally size. So moving on, as our project stands, there are some drawbacks. It's currently limited to Java 7, and that is based on the grammar we chose. Each grammar produces its own antler parser, so in order to produce the intermediate model and walk the AST, we would have to write code for each specific grammar or language. And we decided pretty early on that that would be outside of our project scope, and that would take up too much time when we should be focusing more on how to get the functional sizing output. And another big drawback is that there is some upfront work required to annotate the library files and to note things as inputs and outputs. So the whole process is not as perfectly automatic as we had hoped from the start. And in addition to that, or with that, there's some contextual knowledge that's needed for each project. The estimator or developer needs to know what parts of the source code are important to inputs and outputs, and they also need to take that same process of annotation to every library that's being imported for the project. So now I'm going to get into some of the alternative approaches that we found could be used in the future or could be added into our current design. So one of the big approaches that's been theorized for this project as well is to make use of data mining. So in theory, you could train a system with a large sample size and some upfront training data in order to teach the system how to size a project and produce a functional size output. The con here is that you would need a very large sample size to ensure accuracy, and you need that upfront training data to say this part of the code will contribute to functional size. And again, you reach the same concept that it's very hard to match the functional sizing concepts directly to source code. And in that regard, it's likely that each programming language and each grammar would need its own training data up front as well. So coupled with the large sample size and the training data needed, we found that that would be a bit hard for the scope of our project. Another approach that's a bit more similar to the approach that we take would be annotating the source code itself. So similar to how Doxygen or JavaDocs works, the developer could, as they go, mark certain methods, states, files as important to functionally sizing, whether that's annotating as inputs, outputs, or otherwise. And then the tool would go through and parse the annotations and produce a functional size output that way. So obviously this requires more effort on the developer's side, kind of like requiring them to comment everything and note the important parts. And this approach would likely be more project specific as opposed to language specific. And finally, one of the last approaches that we really didn't dive into is runtime analysis. We more focused on static analysis instead. So some teams have taken to running projects against a series of test cases that would then determine, in that way you could find the boundary of the application, in turn find inputs and outputs and group those into ILFs, EIFs, and produce a functional sizing output that way. So these are some alternative approaches. We acknowledge that they exist, and we don't know if they would have been better or worse than our current approach, or if they would have fit better into the year-long scope of our project, but we do acknowledge that they exist, and our approach is not necessarily the golden solution to the problem. And before we open to questions, just want to give a big thank you to Rick for being an amazing coach all year, and also a big thank you to Lee, our sponsor, for continuing encouraging us and being happy and excited about the project from start to finish. So, thank you.
Yep.
So, you mentioned several times that your project only currently supports the Java 7 language. How far did you go into considering other languages in your design of the intermediate representation of the syntax tree?
So in the first couple of weeks, we met with a professor in the computer science department, Professor Fluitt, and he has a lot of extensive knowledge with working with syntaxes and grammars and creating parsers and interpreters for languages as well as compilers. So we asked him how reasonable it would be to think that we could take two completely different languages, not necessarily like Java and C, but like Java and Python, or Prolog or some weird language that doesn't follow the normal C structure. And he said it wouldn't make sense at all. The grammars to represent them as abstract syntax trees would be so insanely different, and the structures that the program actually runs on, actually runs through, whether it be like a programming stack or something else, they're not comparable in any way. So at least in the approach that we took, which was simplifying it to an internal model that's basically an abstract version of the program itself, trying to combine them into some similar form just wasn't possible. We learned that probably week 5 or something like that when we spoke with Professor Pruitt.
To add on to that too, there's definitely some work that could be done on our design to make our intermediate model more generic. So while that work would still exist to walk the ASTs and produce the intermediate model, there's some more work to be done that would make that model generic so the functional sizing analyzer could walk it no matter what language it came from.
Did I hear that right, that you can recognize like GUI elements? Like what?
Yeah, so we made it was a big thing for our sponsor that he wanted any sort of input and output to be recognized, but he also thought that being able to distinguish between GUI inputs and outputs and, socket inputs and outputs and things of that nature, we'd be able to tell the difference. And so it's the same sort of process where, we didn't really get to show it there, but you would mark it as a GUI input or a GUI output, certain methods, such as like, getting the text from a text field or clicking a button and performing some action off of that. So if those were marked, and they are marked in our standard library, and you could see in our example, we caught a few in our poster.
To support Java only is required.
Yep.
Java has 2 popular frameworks, Swing and SWT.
Yep.
Are you like GUI framework agnostic? You said
GUI framework agnostic.
Like you're not. It doesn't matter what GUI framework you use for Java. You can recognize what.
No, when we talk about the Java standard library, if that includes Swing, then we've made an effort to annotate the Java standard library, including Swing, to annotate things with inputs and outputs. It's not agnostic. If you were to import any other library, you'd have to go in and annotate that yourself. The creation UI helps a little bit with that because it has search in it. So if you wanted to populate it with a library file that includes a new thing, and you want to just search like read, add action listener, get text, things like that, you could in theory just search those terms and like batch edit them all, but it's not agnostic completely enough.
So you mentioned you annotated at least a good portion of the Java standard library.
Yep.
Curiosity, how long did that take you to annotate in the creation tool?
So, since I did that portion of it, it wasn't easy. I basically had to go off of knowledge of my own, all the different things in the I/O package, as well as the Swing and the relevant SWT or AWT packages, to actually go down those routes and annotate them. It probably took maybe 4 or 5 hours to do all of it. And that's just off of my knowledge and the things, like I searched everything in the I/O package. Things in like the Corba package, they probably got left out because I don't have extensive knowledge of Corba. But yeah, it would take a while, and it would be more or less up to, we would prefer if like the developer of a library would make these files instead of forcing, any developer using it to have to make them. But it's just one of those things where you need user input to.
And then that was a big motivation for the creation UI and implementing search and batch editing. So to make that, the project needed to be like accurate, but it also needed to be usable because you don't want to be reading through 1,000 lines of methods and annotating it yourself. So that was a big motivation for creating the UI.
Yeah, and then the other half of that is, I was curious about if there's a way to share. So if I am a library developer, can I annotate this and share this in some way so that everybody else doesn't have to? The example of Swing, for example.
Sure.
So nobody else has to go in and annotate that themselves?
Right.
Is there a functionality for that?
So there'd be the hope for that. I mean, there's no centralized server for this application. It's just a GitHub project. Just like with Antler, because Antler, we had to go and find those grammars. That we probably have a folder somewhere that would allow people to put in their library files that were created. That wasn't really a worry of our sponsor at the time, but that'd be the idea that if this became more mainstream and people began to work on it, this could be used to, create a folder or a brand new GitHub repo where people could store and stash that information.
Let's thank the team.